Hello and welcome to the next RLabs tutorial video. Today we're going to be talking about selecting and removing columns from R data frames. To start with, we're going to consider the essentials of indexing columns for R data frames. Once we've mastered this, we'll move on to see how we can select columns based on certain conditions. We can do this by providing an index that is a logical vector. Also, by then going beyond base R, we can use the dpliers package select and its helper functions that allow us to select column names based on if that character contains a certain character or whether it starts with or ends with certain characters. Okay, so moving back to RStudio, let's open the package ggplots2 and assign to new data frame called my.data the diamonds dataset that is within the ggplot2 package. Let's inspect this new my.data data frame. There's 10 variables. We can verify this by looking at the ncols, and the names of these columns are as such. We've got the number of carats of the diamond, and the cut of the diamond, which is a measure of quality, the color, clarity, etc., etc. When indexing data frames, you provide the name of the data frame, followed by square bracket signs. You then have the choice as to whether to provide one or two inputs for within the square brackets. In the cases where only one input is provided, the default is to address columns. In this case, we're considering the data frame my.data, and we're addressing the first column of that data frame and assigning it to a new data frame. If we run the names function on this new data frame that we've just saved, we can see that it returns only one column, the first column. So that seems to have worked. We can of course go beyond looking at just one column at a time. We can provide one input within the square brackets that considers a block of columns. So this command reads, for the my data, let's index columns 1 through 3. To give us added flexibility, the one input that we provide to the data frame within the square brackets can be a vector. In this case, we're providing a vector that is addressing the first column, the fifth column, 6th column, 7th column, 8th column, 9th column, and 10th column. And the summary of this new data frame shows that it's done this correct. Carat is the first column, depth is the 5th, table is the 6th, etc. When putting values within the square brackets to index columns, we can choose to include or even exclude columns. By providing a negative sign as a prefix, we can exclude columns. This line would then read, for my.data, let's include all columns except that of column 1. So it will return 9 columns, excluding the carat column. So this column that occurred previously has now been removed. An alternative way to do this is to state the data frame's name and the element of interest that you want to get rid of, and assign this a null value. And this will just delete this column from the data frame. Let's rewrite the data again and start from afresh. I've now described what happens if there was just one input provided to index within the square brackets. But if there's two inputs provided, the first refers to rows and the second refers to columns. A blank value within the square brackets means consider all values here. Therefore, this line would read, for the my.data, let's index all rows and all columns excluding the first one. So in this case, we started with 10 columns, we removed the first column, and we're left with 9 columns now, and we've got all the rows. To give you another example of this, here we have my.data, and we're interested in the first 1 to 50 rows, as it's the first input within the square brackets and all columns except for the first column. So let's check if this has worked correctly. Yes, it has. We've got the last 9 columns and we've only now got 50 rows. Another way we can perform indexing is to provide a vector that has logical values. In this case, we're calling the previous data frame, which has 9 rows. We provide it with a logical vector that has 9 values. And if the value is true, we'll choose to include this in the next data frame, and if it's false, we'll exclude it. So here we're left with just 3 variables because we chose to only include the first 3 columns. This can provide us with quite an interesting trick that we can use, as we can perform some conditional statements to derive a vector, giving us true and false values based on a certain condition. So for instance, if we use the sapply function, which looks at the list of names within my.data, ask it to perform the is.numeric function, which returns a true or false value according to whether the column is numerical or otherwise. We can give this vector a name, in this case num, and let's just inspect that. Indeed, it's returned as a vector that gives us true-false values depending as to whether each column is numeric or not. And then we can pass this vector and use it for indexing. This is just one example of how you could use conditional statement to produce a logical vector and then provide this for indexing columns of a data frame. If we want to go beyond the base R approach, we can import the dplyr library. And this allows us to do some other pretty interesting things with conditionally selecting columns. Because we're using the dplyr package, we're going to start using the syntax of the infix operator, which is pronounced then. We approach indexing of data frames now through a distinct function that we've inherited from the dplyr package. So this line of code is equivalent to what you may have seen before, where we index a few columns, but it's the dplyr approach. So it's given the my.data data frame, then let's select these variables. And I just want you to note that a difference between this and how we'd call these variables in name for indexing is, in this case, for the dplyr, it's not necessary for these column titles to be given in quotation marks. And yes, if we run the names command on this new data frame that we've created, it returns 4 columns that we tried to select. Excellent. This line might seem a bit long and cumbersome, but I hope to show you that by now moving to using select within the dplyr package, it opens up a whole host of new helper functions that we can nest within select to perform some pretty interesting manipulations and ways that we can choose columns. Here we've got a similar line of code to above. Given my.data data frame, then let's select columns, and let's select the ones that start with the letter C. So in this case, remember that there was several columns that started with C. Let's look at the names that are associated with the columns of this output, and wow, yes, we've now selected 4 columns: the caret, cut, color, and clarity. I'm not going to spend time in this video discussing the other helper functions, but I'll just introduce them quickly. We have the contains helper function that says if a variable has a dot in it, for instance, then include that. We have the ends with, which is the opposite to the function that I just demonstrated. So if it ends with a certain character like length or maybe some unit measurement, then include that. And you've got the match. If this exact thing occurs within a column, then include it. In summary, this tutorial has talks you through the basics of how to select columns. Also, I've demonstrated we can produce vectors that assess a certain condition, and then we can pass this logical vector into the data frame when performing indexing to allow us to dynamically choose the columns that we want. And finally, using the dplyr, we've found that there's some interesting helper functions that might help us to automate and speed up the selection of columns if we've got a lot to choose from. Thanks for listening to this RLabs tutorial video. If you found this useful, it's possible that you might be interested in our free online Moodle course, or check out and subscribe to our YouTube channel with many interesting playlists about data handling, statistics, and modelling.